today. He flew from Switzerland. He has a studio in Lausanne called Fabric. And it's a great pleasure to welcome Patrick Keller.
Thank you. So maybe just a few words about fabric.ch before I go further into, thank you, I'm small, that's true. Because before I go further into a few projects, I will go quite quickly because I have some material to show. Through the projects I would like to kind of build up speculative ideas about how to maybe inhabit the space, the connected space we are living right now. So about Fabric, maybe it's a collaboration we started 10 years ago. It's a collaboration between architects and computer scientists. So both of us were interested to experiment things. So it's mainly experimental work, research, very few built projects, as you will see. And then it ends up quite often or mostly into art exhibitions, installation, where we can try things. So that's a little bit for our practice. So before getting into a few projects, I would just like to start with this one, which is a very small model we did for an exhibition in Canada, in Montreal, called Dimensional Interferences. And in a way, it sums up the way we understand space today for our part. So it's a very small model, as you can see, computer-generated model or computer-built also model. And as you can see, it's a sort of mashup of axes. So you have different axes that are put together. And in a way, it would be closer. If you would have to describe a space today, you couldn't describe it like you did maybe 10 years ago, 20 years ago with, let's say, this space has a dimension, it has a certain place in time and a certain location on Earth. So that was maybe a way to describe space before. Now it's much more complex, and you have many layers or many stuff getting together at the same time. So for this exhibition, we picked up several locations on the planet that were linked to theory and history of architecture. That was the exhibition. It was located in Montreal, but then we picked up Dubai for the sort of artificial space, the global space. We picked up Athens for the history, the classical architecture. We picked up Brasilia for the modernist city and so on. And it really ended up with all those axes mashed up together at one moment, at a certain time, to describe how the space of this exhibition would be. So you would really need a lot of dimension, or even it's further than dimension, it's X dimension, I would say, to describe the space. And it was really at a certain time, so it will move in time. You would have maybe one axis at one moment, then two, then 3, 5, 1, and so on. So that was sort of the idea for describing the space. And this space we are now in for the conference would be a very good example of this new type of space. I mean, of course, it still has its dimensions, its size, its location, and so on, but many other stuff is going on. Some people are listening, some others are maybe twittering, chatting with friends or whatever. So you have all those interferences of space getting on within this room, and it's different for each one of us. So that's the sort of general idea of what spatial interferences are, or you could also say multitasking space, because many things are happening together. So very complex contemporary space. And in the model, we like this transparency we had in the model, so you can start, I mean, each of this panel has an information about a specific location, the time, the temperature, but you can start mixing the reading, like it's 7 p.m. and 20 degrees. So you have this sort of mixing of space status that appears in this model. So now I will go through project we did for people or for exhibition, and trying to go deeper into those ideas of mashups or interferences, and we'll end up into climate or function, trying to define ways of inhabiting those spaces. So Real Room is a project for Nestlé, which is probably everybody know Nestlé. It's a big food company, global brand. I mean, it has all, the themes we are interested in. And they asked us to rethink their space, saying, what is the space we are living in right now, which is no more like this building is, which is their building. This is a late modernist building with some really typical stuff like horizontal windows, trying to have some transparency to the exterior, pillar construction, and so on. So this idea of transparency, that was the modern also idea, and connection to the exterior, when you go inside, it's no more existing, because the deeper you go into the building, or to the center of the building, the more artificial it is. So for example, here we are in the center circulation area, and you have no more connection to the exterior because you have cubicles, then you have artificial light, you have air conditioning, even the sound is a built-up atmosphere, and everything ends up into a sort of comfortable space. But we were interested into revisiting this artificial, totally artificial space and trying to broaden the spectrum, implying those connected space or bringing other location into this one and so on. Besides, Nestlé is also has also all the dimension like network. It's a big network. There is a huge amount of data information transfer between the location. There are several rhythms. For example, when one location gets to sleep, another one starts. So it's a never-ending organism that works all the time, 24/7, everywhere in the world, and so on. So you have really all those different dimensions. So our proposal was really to have a sort of space sample, a very simple module that is not really about shape, but is more about climate, within which we would create an artificial climate, like temperature, light, humidity, even maybe pressure, and we would get this information for another location on the Earth. So for example, here it would be on a certain latitude at a certain time in space, and we will take this weather information and bring it into this module. This is a front view of the same module. So it's written, for example, here that it's 8 o'clock in the morning, 30 degrees north, GMT -4. But this module would be always 8 o'clock in the morning. Every hour, every 24 hours, it's 8 o'clock in the morning in this module, because we will get every hour the information from the next time zone. So it's 8 o'clock, then the hour after, it's again 8 o'clock, and so on. So at the time you start working with those type of artificial climate, artificial dimension, you can also architecture time, you can architecture distance, you can architecture location, plus dimension, plus shape, plus whatever. So you have all those parameters that get into the building. And then, of course, you could have many of those space samples. So some would be always into the night, some other ones would be always into daytime, some would be cold, someone would be hot. So you have all this sort of mapping of climate into the building. So these are other view getting into a night condition for one of those space sample. This is the inside of a night box. So it's very, as you can see, minimalistic and simple. I mean, the floor is made of mirror, ceiling too, and the walls with glass, so you have a lot of reflection into it. Same when it is daytime. And we didn't go into how it would function. What would you do in a space where it's always 8 o'clock in the morning, or when it's always 11 o'clock and cold, or whatever. So that's a question I will come up a bit later about how to inhabit those spaces. And the whole building would be sort of a global map of the Earth weather into this Nestlé building, inviting all the climates into the Nestlé building. So you have the 24 hours, and you have the different latitude vertically. So these different views, and at night you would have this sort of shape that is the daytime on the Earth that lit around the building. One problem with this project is that it's still totally artificial space. So that was the point. We were interested into that. But it's not very sustainable, of course. You use a lot of energy to do that. So that's maybe a little problem here. So we did this other project. It's for a competition in San Jose, California, which is it's the same kind of idea, but it's a sort of reverse from the previous one, because here everything is free. I would say all the climatic variation are triggered by natural movement, and we design this little tower to increase those movements. Also, the competition was really about building a climatic clock, as they say. So it was about getting information about the climate in different places on the Earth. Is it getting better? Is it getting worse? So that was sort of the idea behind it. That's why also we came up again with this same sort of idea of triggering climate, variation in climate, interferences in climate. So again, those very simple shape. And every one of those boxes, you have 12 boxes vertically, has sensors in it, capture weather information and compare it globally so that you can say, for example, here maybe this box, well, it's the same climate here as in Jacksonville in the United States, or this one is the same as Switzerland, and so on. So it's analyze all the time those variation in climate. So now we have some sections or side views of the building, just to say also how we increase the climate variation in a natural way. So this is close to vernacular architecture or old architecture, where we didn't have technology to air condition the room or whatever. So you have a treatment of the structure that use the albedo index, which is a variation of reflection of the material. So the darker, the more it collects energy, the brighter, the more it reflects it. And the huge cylinder that has the same treatment, but is also bigger at the top than at the bottom, and that reduces the volume of air and makes some difference between the bottom and the top. And a huge also insulation made of air, a second skin that is thicker at the top than at the bottom. Then this really triggers variation in the building. So in the morning, it's cold at the bottom and a little bit hot from the day before at the top. And it gets really warmer at the top at the end of the day, sorry. Same for the humidity, more humidity at the top, then it goes onto the wall, slide down to the little pool that you have at the bottom, and so on. Pollution will be bigger at the bottom too, and so. And again, you would compare all those spaces globally and say, well, this place is like Manaus right now, or this one is somewhere else. So you can sort of experience distance within a same building and gets information about it. So for example, here, the red flag would be the location where, they use more energy, or there is more carbonic gas emission. The green flag would be the good ones, and so on. But again, if you have those invited or compared or channeled location with this building, then you still don't know really how to inhabit this varying space. It implies probably that you have to move into the space to get the climate you like. For example, you want to do something where you need fresh air, you go down, or you want some hot air and humidity, you go up for another activity. So now I'm getting into those questions of how inhabiting those sort of mashup space, hybrid space. distant space, and it's a project by architect Philippe Ram, with which we collaborate a lot, and it's about generating functions for specific climatic condition. So it's an exhibition in the Canadian Centre of Architecture in Montreal. It's made of 2 rooms. On the left, there is a sort of test tube environment. I will show it to you just after. On the right, a display. So on the left, you have this room where you have a lot of sensors that capture the information within the room, and a sort of fake sun that circle inside this space to trigger climatic variation. It's also artificial here. You have the sensor to get the information, and then on the right part in the other room, you have this display that propose some generative way of inhabiting this space. So you have all the climatic information, and then the program proposes a way of inhabiting this space. So it will change all the time because the climatic condition in the other building, in the test tube environment are changing. And it's based on very simple rules like heat, humidity, and light. So heat define the way you are, the type of clothes you are wearing. Light, if you are awake or asleep, so to say, or if you are active or inactive. And humidity define different type of functions, because you can say you will rather bath in a humid and hot atmosphere and maybe do fitness in a cold and dry one. You will maybe cook in also a sort of humid atmosphere. So this is how the program is generating the functions, or the way people inhabit this. It's a sort of SimCity, I would say, as the program, but really defining different way of inhabiting space. So you have some very common function, like many people speaking, wearing clothes into a room, or people sleeping on the floor sometime in a very cold and a little bit humid atmosphere, wearing clothes again. But you also have some people naked, eating some stuff in another room, or cooking naked. It also suggests some furniture which has an in-between status. For example, here it can be either a bed or a cooking device. You have some place to cook on the bed, maybe. And then you can pick up all the space that have the same type of activities, same type of climatic information, and compare what is going on where. And you also have some strange things. For example, here, people sitting on the cooking device, or a carpet where you can cook too. All those hybrid way of inhabiting space. So, this is the way, this generative stuff could inhabit the space I described before, those, interferential spaces, connected space, network spaces. And this is the final project. I would just like to show a couple of images. That's how it could look like when it's built. In a way, it's also an exhibition, again, a collaboration with Philippe Ram here, a French and Swiss architect based in Paris, where you have, again, a sort of climatic and light display that control the climate. One of the lights is heating the room, while the other one just don't do anything. It doesn't heat the room, it's cold light, so you can control the climate. And then you have sensors, again, that capture the information of the climatic display in the room, and then you place the functions according of the temperature. So you have the toilet at a certain height in a dry and cold space. You have the bath in a more hot space, and so on. But it's a totally open space. It's just the climate that triggers the variation, and it ends up in those type of environment. With light heating the room, where you might climb a ladder to go to the toilet, or even climb a ladder to go to the bathroom, and have this, remapping of function into a variable environment. And I'm right at the moment, so I'm finished with this, so it's perfect. Thank you very much.
Thank you very much, Patrick.